Hello everyone and welcome back to my channel. And today we are going to program this part here. So we are going to use two machines, and the first operation we're going to use Integrex or any multitasking machine. And as you see, the part has like big channel interrupted with the pocket through. They have some bosses inside on different heights. So as you see, this one is shorter, this one is a bit taller. We have some cutouts with different angle of the wall. We cannot turn this part because it has some upstand here sticking out. And we have some nice cut into the channel. And we have a lot of pins on the other side. The plan is to machine this on multitasking machine in our Integrex, and then the second operation we are going to put it on 3-axis machine and machine those pins. And the goal is to use just one 3D model. We won't be translating or copying 3D model. We are going to program everything on this one 3D model. Okay, so let's start first with orientating the 3D model. So let's see where is our axis. Oh, okay. So let's go to Planes Manager, and I want to see, this is our top view. So as you see, the part is somewhere in the fresh air away from our 0 point. And before we start programming, we have to orientate our 3D model. We have to set our work coordinate system, our Z0. Okay, so first in the Turning tab, I want to use option Align to Z. And first, Mastercam asks us to select the solid, and Mastercam will automatically select the center of this part. Okay, so now where we want to point x-axis, and then select the face to set our Z0. And in this way we have our coordinate system set to our part. And we have two options here. We can create this new custom WCS, or we can transform this new coordinate system that we just created, transform it to a plane. And we can select one of the existing planes from the list. Use this button here, and then we have our window with plane selections. So I've got +D +Z that I want to use, and now click green button to confirm your selection. And as you see, my X is pointing the cutout and Z is on the front face, which is correct. After you press OK, Mastercam will translate it to the plane we just selected. Okay, so now with 3D model properly orientated and with our 0 point set to the front face, we can add our stock. So let's go here, and we're going to set the stock for left spindle, and the OD diameter on the arc is 91.44, diameter on arc. So you just press the right mouse button and select the diameter of an arc, and in this way Mastercam will measure the diameter you point to. And the length 31 mm. Select OK. And that is on the wrong orientation, so we need to change the stock plane to D + Z+. Okay. Okay, so now we have our stock assigned to our machine group, to our Integrex multitasking machine. And in the next step, we are going to move to Mill Tool Manager, and we're going to select a few tools. So first, let's open that from the Milling tab, Tool Manager, and I'm going to load the tool library I want to use to create my own assembly. So I'm going to change to millimeter tool database, and if you can't find it, just navigate to public documents, share Mastercam 2022, mil, and tools. Open the tool library, and now you have assemblies here, which we haven't got any, and the tools are here. So the cutters, different cutters, and the holders are here. So now here you select your machine group. So of course, first you select the machine from the machine tab, and then you open the tool manager and you can set your tool. Right click, create tool assembly, and I want to create tool assembly from the tool manager, using the tool manager. I want to show you how easy it is. Okay, this is the tool assembly designer. We have a place for holder, and then you can add a tool. Okay, so let's start with selecting a holder. So on this line, when you press on those three dots here, you get the drop down menu with different options. So you can define the holder, and you can build the holder yourself here bit by bit, or you can import from the tool library, and it will use the tool library we just selected in the tool manager. So I want to use a holder. You can use a filter, and let's say I want to use, let's say, BT40. Okay, so these are my BT40 holders, and I want to use ER16, so 0016. Let's say this one. So if you right click on the line, you can see the holder here, edit holder, and you can see how it looks like. Okay, if you want to adjust any of the parts, just click on the part of the tool, and Mastercam will highlight the line for that tool. So for example, if your holder is only, for example, 80 mil, you can change it to 80. Okay, so with this highlighted, I'm happy with the holder. I'm going to click, with this line highlighted of the holder, I'm going to click OK, and this is my holder. So now time to select our tool. Again, drop down menu, import from tool library, import from the library, and I'm going to use a filter, as I want to see only slot draws. Now if you double click left mouse button on the icon of the tool you want to select, Mastercam will filter only those tools. And I want to use 12 mil, but I want to make sure that is the same as I have in my tool room. So I'm gonna press right mouse button on it, edit tool, and I'm going to change the diameter to 12 mil because mine is parallel tool without reduced neck. All the sizes are correct. I'm going to press finish, and then I'm going to click OK to add it to the assembly. So now we have to modify the projection or the stick out length. So basically just grab the holder and drag it down to the position you want. And let's say I want to use 45 millimeters. That's fine. Click OK, press enter, and you can name your assembly. So let's say that is 12 millimeter slotted drill assembly. Okay, and now we are back in our tool library. And with this 3D model for this tutorial, you can download also the tool library. So how to load the tools from the tool library. First, you need to navigate to the folder where you unzipped the tool library. First, you need to tell Mastercam where is this tool library. And this is the tool library that I want to use. I'm going to open this tool library, and in this way we will access the tools listed in this library. There's no holders, there's no tools, we have assemblies. Sometimes you have to leave the window and come back because it's a glitch. Maybe it's only on my computer, but it happens sometimes. So now I've got my new library. I mean, my library that I attached to that 3D model for you guys to download. And if you want to transfer the tools from this or any other library, you just select what you want to transfer. You can just simply press Ctrl A, or use a Ctrl and left click, or just boxed them or window them, those tools that you want to move. And with this arrow up, you can move those tools to the upper window, which is our machine selected, our machine group 2, in our case our Integrex. So I'm going to use this arrow up, and all those tools are copied now to that Integrex. And this is our assembly that we just created using Assemble Tools option in Tool Manager. Okay, press OK, and now we have everything ready to start programming. Okay, so now with tools set up in Tool Manager that are available in our machine group, we need to have a look how we're going to approach to machining this part. So first, I would like to finish this front diameter. Okay, this outside diameter here with this recess. I cannot turn it because we have the feature that is above this diameter here. And I'm going to use a milling cutter to go around. And there's many ways or tool paths that you can machine this outside diameter here, and those faces around this 3D model. And I'm going to use a 2D gallery, and I'm going to use a contour because I want to have a control over the compensation. Okay, and it will give me nicer finish. But I can use any of 3D toolpaths. I can use even multi-axis toolpath, and I advise you to play with those toolpaths and try to use different toolpaths to finish this outside diameter here. First, we will talk about tool plane. So because we are using contour from 2D gallery, I need to tell Mastercam how to orientate the tool. So what tool plane we want to use to machine the 3D model feature with this toolpath. Basically, we have to tell Mastercam what side of 3D model we want to machine. And for example, if I use the current plane, I can only machine the features that I can see on the screen using 2D or 3D toolpath. So if I want to machine this diameter around here using 2D toolpath contour, I have to have tool normal to that face. So basically, I want to machine right hand side of the 3D model, so my tool plane is right hand side. Let's have a look at the machine simulation and I'll show you what I mean. Okay, so we are now in our multitasking machine, and in our Integrex, at the moment we have tool plane set to top. And with this tool plane selection, our tool is orientated as you see now on the screen. So the tool is pointing downwards onto the diameter. And with this tool orientation, our B-axis is 90 degrees. Because we are using 2D toolpath and we want to machine different side than the top, I have to tell Mastercam what side I want to machine, which is this diameter, with the tool pointing the right hand side of the 3D model. And you do that simply by setting your tool plane. And when we set the tool plane to the right, because we want to machine the right hand side of the 3D model, Mastercam will rotate the spindle with the tool pointing towards this face on the right hand side of the 3D model, with the tool plane set to right. When you select the tool axis right, our B axis of the spindle is 0. And with this tool orientation, we can easily use the side of the milling cutter to go around the diameter. And once again, the tool orientation, the tool plane at the moment that you can see on the screen is set to right. Okay, let's go back to our programming screen. And we can assign the tool plane to the operation in two ways. We can pre-select before setting up the operation or inside the operation. Let's look into the first method by pre-selecting the tool plane. So I want to be normal to that face. The face is on the right hand side for the 3D model, so my tool plane is going to be right. And I can select that from the View tab here. You have a right plane, or by right clicking on the programming window. Okay, and when you select the tool right, it will orientate the tool so you can see what you can access. So everything that you can see now, you can machine. And this is your construction plane and the tool plane right, but the work coordinate system has to stay the same for Mastercam to be able to match everything. Okay, so we don't change WCS, we change only tool plane and construction plane. So let's set our operation to the contour. To select my chain, I'm going to use the solid mode selection and edges. And in the 3D mode selection, I would have to select all the edges around. If I change it to construction plane, Mastercam will select for me the one continuous chain on the same Z depth, okay, in the construction plane. And this is what I want to use, but I want to reverse the toolpath because I want to go with the compensation to be left. And this is what I want. Okay, so now we have our chain selected. We go to some basic settings. First, we're going to select the tool, 12mm flat end mill, and we're going to set our cut parameters. I want the compensation to be only control, so I can adjust the size using the machine's control. And I'm not going to leave any stock. I want my contour type to be 2D. And let's go to depth cuts. I'm not going to use actually depth cuts. I want to use multi-passes because I want to have one roughing pass and then one finishing pass. So I'm going to set my finishing pass to 1, which is one finishing pass, 0.25mm for finishing. On the linking parameter page, I'm going to leave the settings at the moment as they are, maybe without the retract. But depth, I'm going to use incremental 0, as you see. And arc filtering, this is my standard settings. I always set it up to 85% towards the line arc tolerance and activate the line arc filtering settings. And I'm going to change the tolerance to slightly bigger. And this is the second method. You can, work coordinate system will have to stay the same across the whole programming of the part, but tool plane and construction plane you can set in this window here. So the tool plane and construction plane will have to be right. Okay. And another thing is the axis combination. It is because we have two spindles on our machine, and the right upper you would machine using the codes for the right hand side spindle, and left upper is using the codes for the left upper spindle. Okay, left hand side spindle. So we're going to use left because our part is clamped on the left spindle. Okay, so that would be all. Let's have a look at the toolpath and then we will come back to linking parameters. This is just a communicate that Mastercam switches off the couch check because we are using cutter compensation on the control. And as you see, we are not machine complete diameters. I want to extend the toolpath slightly, and then we will come back to linking parameters. So first, let's go to lead in and lead out, and I'm going to adjust the start of the contour and the finish of the contour to be the same. Okay, and I will extend 4mm. Okay, that looks better. And now let's have a look at this blue line representing our depth of cut. And as you see, it is on the depth of our edges that we selected as our chain. And it is because our depth is 0 incremental. Incremental means is on the in relation to the edge we selected. So I want to go roughly, let's click this depth button and I can show Mastercam how deep I want to go. And on top of that, I'm going to go deeper 1 mil. That's fine. So it'll be deeper 1 millimeter and it'll be 9 mil from this edge. Okay, that looks better. However, for me it's a little bit too big lead in and lead out. So I'm going to quickly adjust that. Let's go back to parameters. Okay, parameters, and then lead in, lead out, and I'm going to change both to 60% of the tool's diameter. And with this button here, I'm going to copy that to the lead out. Yeah, that looks good for me. And to be honest, I use a lot of 2D toolpaths in my 5-axis programming, and there are two main advantages. Basically now if you look at the screen, we have the point distribution. You have 1 point here, then go here, then next one is just here. So this whole motion is a one linear move, and it is G2 or G3 in your ISO code, and that should give you a nice finish. And also the second advantage is you can control your size on the control because of the tool compensation. And now we have our front diameter finished. So let's have a look into next toolpath, and we want to machine this channel, including those cutouts and this pockets through, two of them, and this lead into the channel. So for that we are going to use one of the multi-axis operations, and for that we are going to use multi-axis pocketing. And this is because I got recently quite a few emails asking about this toolpath, asking about setting it up, and you are right, I did check. And there's not much information about multi-axis pocketing, and as you said, it's hard to get any information regarding this toolpath in using Google or YouTube. So we'll be doing this toolpath more, and even this part is perfect for rotary advance. We will use multi-axis pocketing. Roughing using multi-axis pocketing requires a floor. And the floor is the deepest point that we will go into, or we will machine it. So first, if I select this as my floor, I won't be able to machine through those pockets here, those two. So the best way is just to create a solid or a surface that will represent our floor. So for that, I'll create new level, and I'll leave it active, so everything that I'll create, it will go here. So this is the multi-axis pocketing roughing channel. First, I want to create a solid that will represent my floor. And for that, I need a piece of geometry. I'm going to wireframe tab, and I want to create a circle center point that will be on the front face, and I'm going to start with the size of my inner diameter, which is 75 mil. So 37 is a radius, 37.5, but because I want to use a slot drill with 2mm rad, I need to take off 2mm from the radius, and maybe another 0.5 mil just to make sure that I'm going to pass through those pockets, So I'm going to create the diameter of 70mm that I'm going to use now to extrude my solid. And of course you can also use surfaces if you want. It doesn't have to be a solid, but I found it always easier to extrude a solid. So I'm going to select this, and I'm going to flip it, and my length is going to be up to this edge. That'll be fine. So this is my floor now. This external diameter, as you see here, I will use as my floor. Okay, let's go back to Toolpath Manager, and now we are ready to set our first operation. So navigate to Milling tab, and from Multi-Axis Gallery, I'm going to select my pocketing. And as I mentioned, I'm going to use 6mm bull nose with 2mm rad, and I'm going to set my feed rates. Okay, these are my feeds and speeds, rapid retract. Now let's move on to stock page. And here I'm going to leave this selection at the moment. We'll come back later. My stock might cause trouble a little bit with the back of this part here. And it's because my billet that I set up is greater than the size of this 3D model, and Mastercam will try to machine the back end of this 3D model between the pins. So I'm going to leave this selection as it is, but we will come back later and we fix it and we'll build this toolpath gradually. And the current stock that I selected here is the one you use in the machine group. Okay, so it's job setup. So let's move on to cut pattern page. And here, as my machining geometries, I want to machine the whole 3D model. I'm going to triple click my left mouse button to select the whole 3D model and select only this 3D model, this our part, without this 3D model that we just created to use as a floor geometries. Okay, we're going to use that later. I'm going to leave 0.1 millimeter for my finishing operation, and as my floor geometries, this is where I'm going to use my 3D model I just created. And I want to use only outside diameter, the external diameter of this 3D model. And in the multi-axis pocketing, our cuts are always normal to that floor. This is how roughing works in pocketing. You don't have tool axis control. The tool axis is controlled by the shape of the floor. Press enter. And as I mentioned, we selected only one face, the external diameter of this 3D model. So let's move on. Pattern machining is roughing. We want to rough out all those channels with the pocket through. Strategy, I'm going to offset my cuts from floor. So the roughing passes will be normal to the floor or offset from the floor. And the type, you can use dynamic or you can use offset. I'm going to leave my type as offset. Sorting, I'm going to leave as one way. I want to all my cuts to go in one direction. And I'm going to leave as climb. And also I want to machine by levels. Okay, so one level complete roughing depth at a time. In quick view settings window, you can see that we are using 6 mil end mill width, 2 mil corner radius, so we cannot use undercut option. But this is very interesting feature for the roughing, and you can use this feature only with ball-ended cutters like ball nose, lollipop, or taper mill. And with this feature switched on, Mastercam will tilt the tool to reach undercut areas of your 3D model. So basically, if you have a side pocket, Mastercam can tilt the tool and still rough it out for you automatically. And in our part, it's no use, but I'm sure we'll find in the future something to demonstrate that. As a constant depth step, I'm going to use 50% of my cutters, 6 mil, and maximum step over, I'll use 2 millimeters. And if you press the small plus next to cut pattern, you have a sub page where you can add, if you need, some intermediate slices. I'm not going to activate it because, as I said, I want to rough this channel in one depth, so I don't need this here. But if you need, you have taper walls or something, Mastercam can finish those walls more close to the shape by adding some intermediate slices. There is nothing to set in tool axis control, as Mastercam roughing option doesn't use tool axis control. Your tool is always normal to the shape of the floor. Collision control, I'm going to activate both collision avoidance options, and in linking I'm going to leave these settings as default, and if I have any trouble, I'll come back later and adjust it. Let's move to roughing page, and here I want my approach move to be line, so it is plunge, 90-degree plunge. And entry feed rate, I'm going to do 900 feed rate per minute. In the utility tab, I will change my custom feed rate for clearance blend spline. If you leave it as it is, it will be really slow. So I'm going to change my feed rate for clearance blend spline to 3000. You can change the maximum angle for rotations axis on the miscellaneous page. We're going to leave as default. I'm going to switch my all planes to +D +Z, as this is my main plane I was using. Let's see how the toolpath looks like, and then we'll come back and we'll change the stock, just to show you the difference and how you can fix things. Okay, so this is our part, and as you see, we have nicely roughed out the entry to this channel here. Our pocket through is machined as well, and we have the whole channel roughed out, including here. It is all good, but as I mentioned, I don't want this side to be touched, okay? And this happens because the stock we set up here is big enough to cover the whole 3D model, and this is the stock we used in our multi-axis roughing. And Mastercam, because we selected whole 3D model for roughing, doesn't know that we are aiming to rough only the channel, so it's roughing everywhere where the material is available to machine. And the solution to fix situation like this is very simple. So let's move our pointer one step up, and by the way, you can do it in many ways. You can create a 3D model and assign it as a stock, or my favorite, the most simple solution is navigate to milling tab, create a stock model, and then I'm going to cylindrical along the x-axis, and my diameter is going to be diameter on the arc. I'm going to select this edge, and then the length is going to be distance between 2 points, and I'm going to measure the distance between centers of front and back arc. Okay, and this is the position from this Z0 or our 0 part, so we need to move it back to this 25mm, and this is it. This is all. And now we have a stock model, and we can just simply go back to parameters, go back to stock page, and here instead of stock setup, we're going to select this stock model. Select OK, and Mastercam will generate the toolpath only in places where material is available, which is basically where the channel is. As I mentioned, I will try to use pocketing, multi-axis pocketing more often, just to show you different methods of controlling your tool axis and what kind of extra geometry we need to create sometimes in order to get it to work. This also should answer the question from one of the subscribers, how to rough features that are below the floor level. So the answer is simple. You have to create a floor that is lower than all the features you want to rough. Okay, let's go back to part, and as you see, we do not have any cuts in the back now, and the channel is roughed out, including the cutouts and lead in to this channel, which is really good. This is what we were looking for. Okay, so the part is roughed out, and we can actually now switch off visibility of this level here. So now what we want to do is finish this floor of this channel, okay? Because we left 0.1 for finishing. And for that, I'm going to use along curve. And I will show you how to set your along curve to do passes across and along, okay, around the diameter. And to keep things organized, I'm going to create another level, and all the pieces of the geometry that I need for this toolpath, I'm going to put in that level. Let's spell that. Okay, so let's go and set our toolpath. So from multi-axis gallery, select along curve, and the tool, I'm going to use ball nose, 4mm. I'm going to set my speeds and feeds. For this finishing operation, I'm not going to use stock. I'm not going to assign any stock here. Let's move to cut pattern. And first we are going to select our lead. And this will tell Mastercam what directions we want our cuts to be produced. In the first example, we are going to use edge of external diameter, and the size of this diameter is not important. I can select the edge of the inside diameter and still get the same result. Now we are going to select machine geometries and basically everything that I want to cut. So I want to cut with this toolpath those two floors. And these are the only faces that I'm going to select in here. So my cuts will be produced on machine geometries 90 degrees to the lead. And rest of the settings are okay. I'm going to leave those as default. I'm going to use cutting method as zigzag because we have some cutouts that I don't want to retract the tool. And my step over, I'm going to use 0.15, and this way you'll be able to see passes produced for this toolpath. Our 3D model is quite simple, but if you have more complex geometry in those channels, you can tighten up a little bit the cut tolerance, and that should give you a better finish. And also you can have a look into advanced options for surface quality. Point distribution section here, you can change the maximum distance between each point along each cut, and each of these points is one move for your tool along each pass. Here the output format I'm going to change to 4 axis. Maximum angle step I'm going to leave it as a 3 degree. You can tighten up to get better results in some complex geometry, machine complex parts. And tool axis control, surface with tilt, the rest of them I'm going to leave as default. The 4th axis page, I'm going to leave that as it is, it's okay. And here, of course, we can keep the tool, set some avoidance geometry here, and I'm going to add the whole 3D model so Mastercam is aware of all the faces around. But if I have any trouble, I'll add a second level of the collision control, and third if I need to. As a linking parameters, I'm going to leave it as it is at the moment. We can add some leads in, leads out, but for this example, I'm going to leave as it is. Roughing, I don't need any depth cuts, I've got only 0.1 for finishing. On the planes page, I'm going to change my WCS to my main plane and set the rest of them to match it. Different planes were selected because we had those pre-selected here. Now it's all good. Let's have a look. If you want to activate Coolant, you can do it on this page. And axis combination, again, I'm going to use left upper because my part is clamped in the left spindle of my multitasking machine. Let's hit OK. Let's see the result of our settings, and if we have any trouble, we always can come back and do some adjustments. Actually, it looks quite okay. The passes are generated across the channel and they are 90 degrees to the lead that we selected. Okay, so lead and my passes are 90 degrees to that diameter. Okay, so lead and passes are 90 degrees. So in every point that we are moving around the part, we are 90 degrees to the lead. Okay, so now with having this finished this way, I'm going to copy this toolpath and we're going to set the cuts to be along the channel. And to be able to do that, I need to make new lead. So let's go to wireframe, select line and endpoints, and I'm going to produce the line between the centers of the front and back diameter. Okay, and this way we have a line going through the center of the part, and this I will use as my lead. Let's move back to toolpath manager, and here, oh, I've got the wrong orientation of the toolpath, so I'm going to drag it down. Now move the pointer down. Now my favorite way of copying the toolpath is just grab this toolpath with the right mouse button, then move it slightly down, release the right mouse button and select copy before or copy after. And we're going to adjust the second one. So what I want to do is just change the lead, and I'm going to select this lead we produce. So I need to select the wireframe mode selection and select the center line of this 3D model that I just produced, this wireframe. And now look at this. Even when I rotate the part anywhere I am on the channel, I'll be 90 degree to this lead. Okay, so let's have a look. Now the cuts will be, so remember we just changed one thing, the lead, and our cuts are going the other direction. Okay, so the cuts are 90 degree to the center line. Okay, now let's quickly open the verify window and we'll see if we have any trouble with the toolpath, if we have any collisions. And we are just going to run just very quick simulation just to see if we have any collisions, any trouble with the part. So no collisions as per report, and the part looks quite clear. And let's go to compare. I'm going to use 50 microns comparison against the 3D model, and it's quite good. We have some unmachined areas due to the taper walls, so we have to come back and clean up. We have to face those bits. It's a simple part, so it won't take much time. Maybe front chamfer here, and of course, yes, those through pockets, we need to machine those as well. That won't take much time. Okay, I'm happy with the result so far. Let's go back and let's hit the next toolpath. Okay, and before we move to the next operation, let's have a look at this area. And as you see, my tool is being driven on the top of the surface. And I don't really want to finish that with this tool. I don't even want to touch this surface with the tool. So let's go back quickly to parameters. So at the moment, if we go to that place, you can see that there is a contact point between the tool and the surface here. So what we can do to avoid this situation? Probably normally I would first finish those around before finishing the floor. However, if we want to finish first the floor here, we go to parameters and we're going to use the collision control, and I'm going to activate the second level, and instead of tilting the tool, I will select different strategy, and I want to retract my tool along the tool axis. I'm going to switch off machine geometries and I'm going to leave only avoidance geometries. And when you have that selected, you can tell Mastercam how much stock you want to leave. So how much away from those check surfaces you want to keep your tool away. So let's select it, and I'm going to simply select just those here around. Okay. And you can do with the rest of them as well. I just want to show you on the one example. Okay. So in this way, Mastercam, when we'll be approaching this area here, when we'll be 0.2 millimeter away from those surfaces, it will retract the tool along the tool axis and will move the tool to the next position, keeping the tool 0.2 millimeter away from those surfaces. Keeping this distance you select here. And of course, we have to change the check window, because I want Mastercam to calculate those distances based on the fluid. And I'm going to simply switch off the rest of the tool off. So now let's review it. And look at this. Now if I bring the tool above the surface, I can see that there is a gap of 0.2 millimeter. So now let's have a look at different area of 3D model, and I want to finish all tops of those islands here. So let's first check what size, what depth or what diameter is it on. So I'm going to analyze dynamic, click on the face, and that is 89.4 diameter here. Let's move to the next one. Click on the top of that face. And this one is also 89.4. Let's move to another one. This one look lower, so this diameter will be smaller. 86. Okay, so we can finish those two diameters in the same time. And for that, I'll create a little bit of geometry. So I'm going to navigate to levels. I'm going to activate my new level. I created the level, finish top of islands, and what I'll be using: turn-in and Z-axis control. So with this one active, I'm going to create wireframe and I'll curve one edge. So I want to curve this edge and this edge, okay? And it is only because I want to extend this a little bit. So I'm going to modify length and I'm going to add, let's say 2 millimeters, okay? And I'm going to extend both directions. And there are many different ways how you can do it. And I'm just showing you one of the possibilities. So now we are going to use our turn-in operation. So let's go to Toolpath Manager. So we can see turn-in, and in the Z-axis, I want to use Z-axis contour. And this time I'll be using wireframe, 3D geometry, and chain. This is the direction I want to have, and also this one is the second chain. So I've got selected 2 chains, so I'll be machining 2 areas. I'm going to use tool, let's say 6 mil, and the cut parameters, I want my compensation to be under control, so I can adjust this size to blend better my top of this wall with the rest of the wall, because we will use different operation. So contour type, I'm going to leave as 3D, compensation is left, and I don't need depth cuts. If I would have not the best finish, then I'll come back and add the depth cuts. In the lead in, lead out, I'm going to add for my compensation just 60% will be fine. Okay, perpendicular entry, so we'll lead to the part and then machine it. In multi-passes, I'll add 1 finishing pass. So first roughing, it's only 1 roughing, so it doesn't matter what spacing we will use, because we will have 1 roughing and 1 finishing at that distance. Okay, I'm going to switch off keep the tool down, and in linking parameters, I want to have depth on incremental, top of stock 1 mil, feed plane, I usually add 5 mil, and this is it. This is all what I need here. So let's move on to planes. I want to make sure that my planes are selected correctly. If you want, you can activate Coolant in this setting page here. And then axis control, I'm holding this part in the left spindle, so that is the left upper for me. And rotary axis, I have only axis substitution because we are using Z-axis. And my rotary diameter, I'm going to right click mouse button here, diameter of an arc, and I will read the diameter of this face here with the unroll option selected, because we have to unroll it to flat, then machine and roll it into that diameter. At this point we have everything set up, and let's have a look if we get the result we are looking for. Okay, so we have 1 roughing, 1 finishing, and then we move into the next area, and we have also 1 roughing pass and 1 finishing. We can simulate it with the Z-axis, the rotary axis, and then we can see how this is being machined. 1 pass, retract, lead in, pass, retract, reposition into the next area, one roughing and one finishing 0.5 mm distance. That's okay, this is cool. So we have another section of the 3D model finished. With our next toolpath, I'm going to show you how you can easily, with few clicks, finish those all fillets. And also, if you want, you can also use it to finish the walls. So for that, I'm going to use Multiaxis toolpath in the milling section. And again, I'm going to use parallel. So first I'm going to set my tool and my feet. Okay, so these are my feet and speeds. I'm not going to activate any stock. In the cut pattern, I will set my all cuts to be parallel to surfaces. And in the parallel, you can select multiple surfaces that are not connected. So I'm going to select this floor and this floor. So all my cuts will be parallel to that floor. And now I have to tell Mastercam what I want to machine. So we are going to leave machine geometry offset to 0 because we are finishing. We don't want to leave anything on top of the surfaces. I'm going to use while you hold Control, click left mouse button, and it will select all matching fillets. And in this way, we have all fillets selected around the part. Okay, so Control, click, select matching holes on fillets. Select OK. And here again, to get better finish, change that to a bit tighter. Let's actually change it to 0.005. And in the area type, I'm going to change this to determine by number of cuts. And I just want one cut to clean this fillet around. All this is good. Okay, I'm going to leave as it is. So now let's move on to the next pages. And also, of course, if you have any trouble in those areas and you have a bit squarish finish on those round fillets, round walls, you can change the maximum point distribution to a bit tighter, and in this way you can get better finish as well. Next up, advanced options for surface path patterns. We don't have to change anything here. On the margins tab, we don't have to change anything here. We don't need to add internal tool radius as the fillet size and the corner radius are the same. And we are making only one cut along the bottom edge of the fillet. I don't have to change anything here. Tool axis control page. Here I'm going to use 5 axes and surface with tilt. Ortho to cut direction at each position, so wherever you are is going to be 90 degree because we're going to leave those as 0, 0. So in the collision control, I'm going to leave the first as a trim. So trim and link toolpaths and trim collisions only. And on the second one, I'm going to tilt the tool. And what I want to do is change those to the front, so just the tool. And I want Mastercam to tilt the tool using side tilt if we are to avoid collision with those two surfaces here. This one, sorry, this one and this one. And same on the other side. This one and this one. Because our tool is going to be normal to the floor, and in this way we would cut the corner of the top of this lead into that floor. Okay, this entry here, and in this way Mastercam will tilt the tool using side tilt to avoid the collision while machining those fillets. Linking, I'm going to leave those this linking as you see here. If I have any trouble, I can come back and adjust that. Let's preview the toolpath. We should have one line around here Okay, it looks fine. Let's accept the settings and quickly run backplot to see the tool position along the cut. Okay, so now we are at the stage of programming that we have quite a few toolpaths finished, and what I really want to do quickly, just go to the verify and run the simulation to see if we have any problems. So I'm going to select all the toolpaths, hit verify, and in the verify window I'm going to just quickly run the simulation on the fast speed, as I'm interested only at the result. Also, let's quickly change to the report window so I can see if we have any collisions. Okay, so it looks good. We don't have any reported collisions. Let's go to compare tab, and I want to compare the result to my 3D model, and I'm looking for the green color everywhere. However, I see already the red spot, which is not good. We have some collision, or maybe not collision, but some scratch or over-machined area of up to -0.2. Let's go around to see if we have any other scratches or problems. Now, rest of the 3D model looks okay. We have some unmachined areas like through pockets and some of the walls like here and here, because the walls are tapered. And the top of this face, as you see here, I'm going to use to explain this merging section of the parallel toolpath, and I'll show you how it works, this adding internal radius. Alright, let's go back to programming window, and I want to investigate what is causing this scratch on this middle channel. And it was section here. Okay, so I can see that parallel toolpath is some trouble with the pass here. Okay, let's have a look first quickly through the other operations and see if we have any. Okay, that is quite deep plunge. I can't have that. Let's select all the toolpaths, deselect this stock model, and we do not have any other problems with the plunging. Okay, so let's go back to this along curve first. And if we track down what is actually, where is it going? So it's plunging here and then it goes here. Okay, so it is trying to reposition to the next area. So it's something to do with the linking. And I know it's trying to get to the next position direct, okay, using the linking option direct. So that's easy to fix. Let's go back to parameters. And then in the linking section, yeah, default linking direct and large gaps direct. So let's separate those two, and we have different linking for small gaps, and we're going to set something different for large gap. And I want to, for large gap, I want to set some big value and retract it to, let's say, fit distance. And I want to apply this linking only for the distances, for the gaps greater than, I'm not sure how much, how long distance it is. Let's say 50 millimeters. I'm only guessing. Let's preview the toolpath. Oh yes, okay. So that's fine. We don't have this plunge, but I can see that this retraction is way too high for my machine, and it will alarm out. So let's go to clearance area, change that to cylinder, maybe direction automatic, and radius, let's say 50 mil. Okay, that's fine. Hit OK. Yeah, I can live with this. Okay, so that's fine. Now let's move to our scratch in this parallel operation. So here, and what is causing this? Okay, so I wanted to drive this toolpath to outside here along this edge. So let's have a look into the parameters, and I'm going to check if my drives are okay. So let's go to cut pattern, and let's hit the drive machine geometries. Yeah, okay. The fillet is selected. However, I didn't want to select this wall here section. And when we were originally selecting our drive surface or machine geometries, we used Ctrl-click to select matching fillets. That's why that was selected, okay, with those fillets around. This might actually cause a problem because we have some collision control that takes into the consideration drive surfaces. And before we move on, let's have a closer look into this problem. And it looks like this path was trimmed out because it doesn't follow my drive. So let's go to collision control. And as you can see, we have the first stage. The strategy is trim and drilling toolpath for collisions. And because we had this top of the wall selected as a drive and the wall is tapered, Mastercam trims it out before tilting the tool in second level of collision control. So let's preview the toolpath. So we are now going to outside, okay? So we are tilting the tool to avoid the collision with the taper wall, but I can see that is still probably direct linking because we are not retracting here. So it will still scratch the part. On the linking page, I'm going to change my default links and I want to retract to fit distance again. Well, maybe I'm going to adjust my air safety distance and entry fit and exit fit distance to 5 mil, all of them. And let's preview it. Oh, nothing. Oh, because I've changed only small gaps, but our large gap starts from 0. So we need to adjust the large gap if we don't put the value. And there it is. Okay, I'm happy with this retract. Let's see the other sections. And we can see the retraction to fit distance above the pocket through. And again, let's adjust our first entry and last exit by changing the clearance area to cylinder and radius 50 mil. Okay. And yes, this is the result that I'm happy with. After fixing last operation, I want to confirm if everything is okay. So let's run the quick simulation and verify window. And we had this red area close to the entry to this channel. And let's watch if we still got it there. I've noticed that our tutorial is already over 1 hour long. So let's finish rest of the toolpaths in the second part of this tutorial. And everything is recorded. I just need to put it through my video editing software. And I hope that I can release the second part in a couple of days. Thank you all for watching. Thank you for subscribing to my channel. Thank you for all the coffees, all the comments. And if you like my videos, if you find my tutorials useful, just don't forget to hit this like button, subscribe to my channel, turn on the bell notification so you don't miss any future tutorials and videos. Take care. See you in a few days.